Hello, welcome back. DangTeach at CCSD. We're going to cover some more math. This is math 3 of a 5-part series. And we'll be covering temperature conversions, Fahrenheit and Celsius temperature conversions. We'll do some order and supply dosage calculations and extend that to weight-dependent dosage calculations. It's very important that you take a look at math 1 and 2. You should be able to convert within the metric system and between unit systems, English metric conversions as well. If you're not savvy on those points, go back, review, practice, and it'll make temperature conversions, order and supply a lot more simpler. All right, let's begin. So we have 3 temperature scales in use. We have the Fahrenheit temperature scale, and that's what we use in the United States and only 1 or 2 other countries in the world. So freezing for us is 32. Room temperature is about 70, and boiling is 212. In the metric system, 0 is going to be freezing. 21 Celsius is about room temperature, and boils at 100. So this makes more sense. You start at 0, you end up at 100. And lastly, we have the absolute temperature scale, or the Kelvin scale. And all it is you take your Celsius and you add 273, and you get your absolute temperature scale in Kelvin. There are many equations that you can use for converting between Fahrenheit and Celsius. We're not going to worry about Kelvin for this course. So use the one that's best for you. I'm going to give you an equation that I like to use because I can go from Fahrenheit to Celsius or Celsius to Fahrenheit. So 9C equals 5F minus 160. And all the other equations out there, they're just a rearrangement of this equation. Okay, so for the first few examples, we're going to convert from Fahrenheit to Celsius. So we have 100 Fahrenheit, 100 degrees Fahrenheit. We want to convert that into Celsius. So you'll start with the equation. You'll always start with the same equation. And anytime you see an F in the equation, you're going to insert 100 in place of the F. So whatever temperature they give you, you're going to replace the F with that number. So here we have 9C equals 5 times 100 minus 160. So I rewrite everything. That way I don't miss anything and make a mistake. So from here, all we have to do is solve for C. So let's simplify some of our expressions. So we can simplify 5 times 100. Or sorry, yeah, 5 times 100 gives us 500. We can simplify this difference here, 500 minus 160. So we end up with 340, and the last thing we need to do is divide both sides by 9. Right? So when you do that, you get C equals 340 divided by 9. And that comes out to about 37.8 degrees. All right, let me have you try this one, and then we'll go over it. So if you need to, pause the video for a short second. So always start with the same equation. This time our F value is 70, so we'll plug that guy in. Next step is to solve for C, so we can start simplifying this expression. So we'll do 5 times 70. Then we'll simplify this expression here, 350 minus 160. And we're left with 190. The last thing to do is to divide both sides by 9 to isolate your C. So 190 divided by 9 gives us a Celsius temperature of 21.1. So that's about room temperature. So if you see the weather report in any other country, you'll notice that it's in degrees Celsius. So about 20, 21, that's going to be a nice, pleasant day. Okay, now let's go the opposite, the reverse way. Let's go from Celsius to Fahrenheit. So we'll start with the same equation. That's why I like this equation. You can use it for Fahrenheit to Celsius or Celsius to Fahrenheit. The only difference is, in this case, anytime you see a C, you're going to replace that with the Celsius value. In this case, it's 50. So we got 9 times 50 equals 5F minus 160. So we inserted the value for C, and now we need to solve for F. So let's simplify this expression, 9 times 50. We get 450. And we want F by itself. So in order to get F by itself, we got to get rid of this negative 160 by adding 160 to both sides. So if you do one thing to the equality, you got to do it to the other. Now we can simplify this expression and this expression. Of course, this right-hand side goes to 0, and the left-hand side becomes 610. And our last step is to divide both sides by 5. 610 divided by 5 gives us a Fahrenheit temperature of 122 degrees. All right, you guys give it a try. I put a negative sign here. Let's see if you can step up to the challenge. So pause the video, give it a try, and then we'll go over it. Okay, start with the same equation. This time we're going to plug in negative 10 for C. So we got 9 times negative 10 equals 5F minus 160. Let's simplify that expression. We get negative 90. And to isolate the F, we got to add 160 to both sides. So this expression becomes 0. This becomes a positive number. 160 minus 90 is a positive 70. And then we divide by 5 on both sides. F becomes 14. So negative 10 degrees Celsius is 14 degrees Fahrenheit. And does that make sense? Well, yeah. So if Celsius is below 0, that's frozen. And if Fahrenheit is below positive 32, then that's freezing. So that would make sense. Now, if you didn't put in the negative sign and you got some weird number, then you may want to double check your work. Order and supply. So the doctor will give you an order, and you have to fill the order based on the supply you have. The doctor usually does not know what the supply strengths are in the pharmacy. So for sometimes you may have to adjust the amount of supply to give. So for example, we have a supply 50 milligrams per tablet. And just like in Math 2, where we use any equality as a factor of 1, we can also do this for our supply strengths. So 50 milligrams equals 1 tablet. So 50 milligrams over 1 tablet, or 1 tablet over 50 milligrams, would equal 1. So we're using the same factor label method and dimensional analysis that we did for converting between English and metric units. So if you're still having trouble with that, go back, review the video, work on some more items, and then come to class with the questions, and then we can continue on with the order and supply. Okay, so we have order and supply. So the first thing we do is let's start with the order. So the order calls for 10 milligrams per dose. So I'll write it like this, 10 milligrams per dose. And I need to now multiply that by 1, a factor of 1. So my supply is a factor of 1. The factor of 1 I need milligrams here at the bottom. Because I have milligrams here, I need cancel out. So I'm going to put my supply as 1 tablet per 5 milligrams. The 5 milligrams cancel out, and take a look at your units. You're left in tablets per dose, and the question asks for how many tablets per dose. So if you do it the long way, it'll help you verify the answer better. So just simplify by multiplying the fractions, and you'll get 2. Right? So that's the long way. Let me teach you guys a shortcut. So the shortcut is order over supply. So as long as they're in the same units, here we have an order of 10 milligrams, and our supply is 5 milligrams. So these units need to be the same, and you'll still end up with the 2. So if in doubt, it's always order over supply. In this example, our supply is a liquid medication. So it's not 1 tablet or 1 unit, it's per 5. So we're going to have to do something with that number. So let's start with the order. So the order is 375 milligrams per dose. So we'll write that as our fraction. And now we're going to multiply by a factor of 1. And the units we want at the bottom are going to be milligrams. So we'll put 5 mLs over 125 milligrams. Our milligrams cancel out. Let's take a look at our units. We are left with mLs per dose. The question asks for mLs per dose. So let's do the calculations. 375 times 5 divided by 125. And you'll get 15 mLs per dose. So let's do the shortcut on this one. So last time we did order over supply, but that is if the supply was per 1 unit. In this case, it's per 5 mLs, so we'll need to multiply by that amount. So let's plug in the numbers. So our order is 375 milligrams. Our supply is 125 milligrams per 5 mLs. So you'll multiply by that amount. And that should equal to, 15. Order over supply times the amount. Now, if the units don't match, you'll need to make them match. So here I put the order, 500 milligrams per dose. And I had to convert this into like units. Right? So for every 1 gram, there's 1,000 milligrams. So this is just a factor of 1. That way our milligrams will cancel out, and we're left with grams per dose. But that's not what the question asked for. The question asked for tablets per dose. So we got to convert this gram to tablets. So last thing, multiply by our supply. So our supply is 1 tablet equals 1 gram. The grams cancel out. Now let's take a look at your units. Tablets per dose. They wanted tablets per dose. Crunch the numbers and you'll come up with half a tablet per dose. We can still use the shortcut here, but we got to make sure that our order and supply are in the same units. So what I can do is right off the bat convert this 1 gram into 1,000 milligrams. And from this point, all I got to do is order over supply, and I'm done. All right? Since this is a 1 here, there is no amount, and you'll end up with the same half an ml. All right, let's try this one. So we got half a gram per dose. Our units are not the same, so we may want to make them look the same here. This time I got to put the grams at the bottom to cancel it out. And our next step is to multiply by the supply. So the supply will need the milligrams at the bottom. 5 mLs per 100 milligrams. Crunch the numbers, double check your units. We want mLs per dose. We're left with mLs per dose, so we're pretty confident we set it up correctly. So about 25 mLs per dose. So let's use our shortcut now. Order over supply times the amount. Take a look at the units of your order and supply. Make sure that they're similar. So for this one, I'm going to change the half a gram into milligrams. So that's my order, 500 milligrams. Supply is 100 milligrams per 5 mLs. 500 divided by 100 times 5 will equal 25. All right, you guys try these two problems. So go ahead and pause the video for a moment, give it a try, and then come right back. Okay, for the first one, let's take a look at the units. This guy right here is in grams, so I'm going to change him to milligrams. So 10,000 milligrams. And from here, all you got to do is order over supply times the amount. So our order is 50 milligrams. Supply is 10,000 milligrams. This is per 100 mLs. Crunch your numbers. 50 divided by 10,000 times 100, and you'll end up with half an ml per dose. The second example, micrograms and milligrams. I'll change this guy to micrograms right off the bat. That way, all I have to do is order over supply, and I'm done with this guy. Bam, 4 tablets per dose for that one. Okay, now let's figure out how much of the supply to dispense for an entire drug regimen. So this is what's known as quantity sufficient. Give them enough quantity to last them, in this case, 10 days. So let's take a look at the order. So the SIG is the order. Per dose is 100 milligrams by mouth 4 times a day for 10 days. So the first thing you want to do is to figure out how much of the supply per dose you will need. So we need 100 milligrams per dose, and our supply comes 1 tablet per 50 milligrams. All right, next step, we're going to multiply by the number of doses in a day. In this case, 4. And lastly, we're going to multiply by how many days. In this case, it's 10 days. Go ahead and crunch the numbers, and you will find that for a 10-day supply, 100 milligrams 4 times a day, that is going to be 80 tablets. All right, so let's do the shortcut. So the shortcut is you'll start with your order and supply. So in this case, our order per dose is 100 milligrams. And the supply comes 50 milligrams per dose. So we will need 2 tablets per dose. So it's 2 tablets to get the 100 milligrams. You multiply by the number of doses in a day. So we have QID for 4 and for 10 days. So 2 times 4 times 10 will give you 80 tablets as well. So that's the shortcut. In this example, we'll need to contend with an extra number, the amount number. So we'll start similarly with the order. We need 100 milligrams per dose. And how many doses in a day do we get? So every 8 hours, that's going to give us 3 doses in a day. We'll multiply by the supply to get the amount. 3 doses a day. And then this regimen is going to be for 14 days. So it asks for how much of the supply. We're left with mLs, and the mLs is in supplies. So that'll take about 315 mLs. So let's do the shortcut for this one. So our first step is order over supply times the amount. So that means we need 100 milligrams. Our supply comes 200 milligrams per 15 mLs. So that's going to give us 7.5 mLs per dose. So to get 100 milligrams, it would take 7.5 mLs of our supply per dose, and we're going to do that 3 times a day, every 8 hours, for 14 days. 7.5 times 3 times 14 will equal 310. All right, I'll have you guys give these 2 problems a try. So go ahead and pause the video, and then when you're ready, come back. All right, for this first one, I'm going to go ahead and change the grams to milligrams right away. And then I'll do my order over supply times the amount. So the order is 100 milligrams. The supply is 10,000 milligrams per 100 mLs. Q12H is going to be 2 doses in a day. And we're going to do this for 30 days. All right, so let's crunch the numbers. 100 divided by 10,000 times 100 times 2 times 30. You'll end up with 60. For the next problem, you're going to have to add. You're going to have to add how much they take there with how much they take there, and then multiply by 14. So anytime you see an and, you'll have to add. Half a gram, let's change these to milligrams. So 0.1 gram, is going to become 100 milligrams. 0.2 grams will become 200 milligrams. So it takes 2 tablets here, order over supply, 100 milligrams per order, TID. Our supply is 50. So that's going to take 2 tabs per dose. So your 2 tabs times 3, well, that's 6. So your meal doses are 6 tabs in a day. But at night, you still need 200. So 200 milligrams over 50, that's going to be 4 tabs. So this nighttime, you'll need an extra 4 tabs. So in the entire day, you'll need 10 tablets for 14 days. And that should come out to 140. All right, the last topic for today is weight-dependent dosing. So we normally dose based on body weight in kilograms. So the first thing we'll need to do is to convert from pounds to kilo. So you do that by dividing by 2.2 pounds. So in this case, 165 pounds is going to be what we'll use to determine the order. So we have the order of 5 milligrams per kilogram per dose. So how many kilograms they have, you'll give them 5. So it's written this way, but the expression is like this: 5 milligrams per kilogram dose. That way our units cancel out, and our question asks for milligrams per dose, and we're left with milligrams per dose. complete the math calculations, and you should end up with 375 milligrams per dose. This next example has one extra step. So instead of giving them the drug all at once, we're going to divide the dose into 3 and give them a third of the drug, their daily amount, every time. So let's figure out how many milligrams of medication per dose. So weight into kilos, and then we'll multiply by the order, which is 25 milligrams per kilogram day. And to divide by doses, you get 3 doses in a day. So every 1 day, there are 3 doses. Days cancel out. Let's take a look at your units. Milligrams per dose. And we're left with milligrams per dose. Crunch the numbers, and you should give them, or they'll need 511 milligrams per dose. All right, let's put this all together. So let's review. The first step you need to do is convert pounds to kilos. So once you get their weight, right, you're going to use that number for the next step. Take their weight and you multiply it by the order, right? How much drug they need per day. Once you get that daily amount, you're going to divide that by the number of doses. So not all problems you'll need to divide by doses. So in this case, we'll need to divide by 3, and that's going to give you your per dose amount. And then last step, you're going to do order over supply times the amount. Right? So I'll give you guys an opportunity for some extra credit. So if you're in my on-ground or online class, just go ahead and email me the answer for Math 3. All right, preparing us for next time, we're going to work with solution percentages. So here are some definitions, flashcard items to make. So D5W is dextrose, 5% water. D10, 10% dextrose. D70, 70% dextrose. So those are the easy ones. Get those out of the way. Next we have NS. NS stands for normal saline. So normal saline is 0.9% salt, 0.9% sodium chloride. So by definition, NS is always going to be 0.9%. We have half NS, or half normal saline, and that is half the concentration of normal saline. So if normal saline is 0.9, then half normal is 0.45. The next salt solution is quarter normal saline, or quarter NS, and that strength is 0.22% sodium chloride. And lastly, we have sterile water for injection, or sometimes it's sterile water for irrigation, and that is just water, so it's 0% content or 0% drug. That concludes math part 3. Next time we'll continue our math with math 4. We'll get into solution percentages and allegations. Allegations is using percent strengths to fill your order. Once again, everybody, thank you for joining us. And if it's your first time, welcome. And if you've been coming back, there'll be more videos coming up shortly. Thank you. And as always, you guys have a wonderful day.
You don't give a dang, I don't give a fong.